Okay, today we're going to take a look at finding limits analytically of sine and cosine. Now, because this is going to take us at least 20 minutes, I have a two-part video for you. So this is part A. Alright, so what you need to know is there are a few properties for sine and cosine when it comes to limits. These two special trig limits have a theorem. Now, eventually we're going to be able to analytically show this theorem, but right now we don't know L'Hopital's, so we're going to have to use it as just face value. So what we're going to take for face value is this: limit as x approaches 0 of sine x over x is equal to 1. Now we can look at this graphically and see that there's a hole there and that the height is 1. But for now we're just going to take a look at it and we're going to use it just as is. Also another one, second part of the theorem, limit as x approaches 0 of 1 minus cosine x over x is equal to 0. Now this is important that you know that it has to be 1 minus cosine x, and also they both have to have x approaching 0. If anything is different, then the theorem doesn't work. Now there's always a however. However, please note the reciprocals are also true. So if we take the reciprocal of sine x over x, we get x over sine x. This is also equal to 1 as x approaches 0. Same thing pertains to 1 minus cosine x over x. The limit as x approaches 0. If I take the reciprocal, it also works and you get 0. Okay, one other theorem and then we'll be good to go. Okay, so the theorem is basically this: if I have a limit as x approaches 0 of sine a x over x, I just get a. So meaning if you have a value there like sine 5x over x, you would just get 5. And then the same thing for the one below here, number 2, limit as x approaches 0 of sine ax over sine bx. That's just equal to a over b. To actually write it out for you and show you, that means that if you have limit as x approaches 0 of sine 17x over sine 5x, your answer would simply be 17 over 5. Alright, just to review, what does it mean to solve analytically? Basically, we're going to use Algebra 1 or Calculus. Let's go ahead and begin. Okay, I have the rule that we're going to use right alongside, or the theorem, the problem, but the whole goal is, even if you have tangent x or any other trig function besides sine and cosine, you want to try to make that look like sine and cosine, and you want to try to, more importantly, make it look like one of our properties, or else we can't solve. The reason being is this: if I plugged in a 0 here, you get tangent 0 over 0. That makes it undeterminate. You get 0 over 0. So I need a theorem to break this into pieces. Okay, so let's go to its simplest form. We have limit as x approaches 0, and remember, we're not getting rid of the limit till we evaluate. And I can say that this is equal to, at least tangent x, sine x over cosine x, and in this case all over x. So my goal is, because I don't have a 1 minus cosine x, my goal is to make it look like number 1. Okay, so if I rewrite this a little bit, if I take the reciprocal of the denominator and I multiply it times the top and the bottom, I end up getting limit as x approaches 0 of sine x and then over cosine x, and it's times x. So all I did is just multiply sine x times 1 is sine x, and cosine x times x is x cosine x. Now I can rewrite this a little bit. Limit as x approaches 0 of sine x over x times 1 over cosine x. Now notice here, I've got my property. So this right here generates 1, and it's just something you're going to have to memorize for now. Alright, let me grab Mr. Green. So I know this is equal to 1. Now when I evaluate cosine x and I put a 0 in, that just makes 1. So basically what you have here is 1 times 1, so the answer would be 1. And notice I drop the limit as soon as I evaluate the functions. Okay, here's another one. Alright, great. It looks like I can probably create 1 minus cosine x over x with this function. So first thing I'm going to do is let me rewrite this. Limit as x approaches 0 of, and I can say that this would be x over 1 minus cosine x times x over 1 plus cosine x. Okay, so we're in good shape here. Now if you're like, why are you doing all this work? Well, if I plug in a 0, I get 0 over 1 minus 0. Oh, almost made a mistake there. Let me erase this here. Cosine of 0 is 1. So we end up getting 0 over 0. It happens to the best of us. So that's undeterminate. So I need to use our property. Now let's scroll up here. Now it looks like I'm going to use this property right here, number 2. But it only works if it's 1 minus cosine x. And the reciprocal works as well. So it looks like this piece right here is going to generate 0 for you. But I still have to evaluate the second piece. So if I evaluate the second piece, I get 0 over, in this case, 1 plus 1, which makes 0 over 2, which is just 0. Oh, yeah, that looks good. And then so I get 0 times 0, which is just going to be 0. So that's your answer. Alright, to use our other property here, it looks like I'm going to be using number 1. Let me grab another color here, liven things up a little bit. This is limit as x approaches 0 of sine 3x over x. Now we're just going to take it just as is. Like I said, later on we'll use L'Hopital's theorem to show analytically. But this is just equal to 3. Simple as that. Okay, let's take a look at part B. We also have a theorem for this one. It's right here, number 2. And if I look at this, because I have x approaching 0 and it's sine 3x over sine 5x, it's just simply a over b, which is 3/5. Pretty easy. Alright. It says evaluate each basic limit. Okay, so we're going to use limit properties here. We sort of used them earlier as well when we were plugging in. So I could rewrite this. I can say that this is 1/5 times the limit as x approaches 0 of sine x over x. And we know that this right here, due to our theorem, is equal to 1. So we just simply have 1/5 times 1, which is equal to 1/5. Let me scroll down here. Okay, almost done here. If I rewrite this, I get limit as x approaches 0 of sine x over x times sine x. Okay, I have my property right here, which makes 1. And then if I evaluate, and this is really a trig property, but this is also a limit property, meaning if I have limit as x approaches 0, I can basically split this into 2 different limits. It's product property, and for limits, this would be sine x over x times limit as x approaches 0 of sine x. So I can evaluate both of them. Before I was just evaluating each piece, but just know you can split it up like this as well. So I get 1 here, and then I get 0 here, and you're multiplying, so you just get 0. Alright, like I said, this is a longer topic, so going back to our learning goal, students will be able to solve limits analytically of sine and cosine. I do think you'll be able to do this, but come check out the next video, part B. I'll see you in the next video.